Hello everyone, welcome in a new video. In this video, we are moving further in a process synchronization. Okay, so we discuss about a fork system call. There is a one more system call which is very important, which is a wait system call. Wait system call. Wait system call. So what basically this wait system call does? Wait system call is basically wait the child process. It basically when you call wait, so what it basically does, it call the process until one of its child process completed. It block the process, it wait that process, the parent process until the child process is not completed. Okay. So this is what a wait system call. What is a wait system call? A call a call to a call to wait, or you can say block the calling process. Block the calling process means the parent process is basically blocked until one of its one of its child process are not completed, is not completed. One of its child process is not completed. Until then, the main process, the parent process, is basically have to wait. So this is what a wait system calls. So what it does, it basically wait the main process, wait the calling process until the completion of its one of the child process. And uh, after the child process terminate, means it when the child process completely execute, when it leave the CPU, when it terminate, the parent process then continue to start execution. Okay, so after uh, completion of child process, parent process can start, or you can say resume the execution. Okay. So this is what a wait system call does. It basically block the parent process, or you can say block the calling process until the completion of one of its child process. Let's understand with an example, like you call a process, you call basically a fork, and you wait, and you use wait. Okay. So we have a two processes, parent process and a child process. Okay. Parent process and a child process. So what basically it does, both the processes are basically want to print hello. Okay, both the processes have to print a hello. So what basically does, both the if wait is not called, if a wait is not called, then what basically happen, both the process is running continuously. Okay, concurrently, both the process is executing concurrently. Okay, but when a wait is called, if a wait is called, then first of all the child process is completed. After the completion of a child process, when child process terminate, then the cursor move towards the parent process. Okay, so till the completion of a child process, parent process have to wait. Okay, so what basically it does, it print hello, it print hello. Okay, it print hello. After when child process print hello, after child process print hello, cursor move towards the parent process, and then parent process print hello. So the hello will look like first of all this child process and the parent process. But if wait is not called, then what basically happen? First of all the hello of a parent process is printed, and then child. Okay. So if wait is not called, both the process run concurrently. If wait is called, then child process firstly completed and then moving towards the parent process. So this is what a use of a wait. Okay. So now let's move towards the next and a very important type, which is a process type. A new topic is process type. A new topic is process type. So what is basically a process type? So process is basically of two types. independent process and you can say communicating process, or you can say coordinating process. Okay, so process is of two types: independent process, and the other type is process is called communicating, or you can say coordinating, coordinating, or you can say cooperating. So process is of two types: independent process and communicating process, coordinate process, or you can say cooperative process. Okay, so what basically a independent process and what basically a communicating process? Let's understand this thing. So the independent process is those kind of a process which do not communicate with the other process. Independent process are those kind of process which is not communicating to other process. Okay, so the process which do not communicating with other process, which do not communicating with other process. Let's, for example, if there is a one shared resources and both the process want to use that shared resources. Let, for example, like this is what a shared resources is. Let's say P1 and P2. So what basically an independent process is, if the value of X is like 20, if value of the shared resource is 20, so what basically happen is P1 take that 20 and P2 is also taking that 20. Okay, both the processes take that particular value. But what happen in a communicating process, if P1 communicate with the shared resource which value is 20, let's say the value of X is what 20. So what P1 does, P1 change this value. For example, from 20 to change the value to 10. They do some operation, they subtract 10 from the X and the result is basically a 10 which is basically stored in that X. Now, when P1 is complete their execution, what happen is P2 come and take that shared resource. So what happened? What the value basically the X that P2 get? The value of X is 10 because P1 is change the value of X from 20 to 10. From 20 to 10. So the value of X in P2 with P2 is basically 10. Okay. So this means a communicating process, a coordinative process. Okay, but if both the processes using the one single value, no change, means 20 is using by P1 and 20 is used by P2. So this is means this process are independent process. They are not a communicating process. Okay, so the process are not communicating. Okay, so I hope you understand by independent process and a communicative process. So what is a communicative process? The process which communicate with other process. The process which communicate with other process. The process which communicate with other process. This is what a communicating process, or you can say a coordinating process is. Okay. So this is what I hope you understand about these two kind of a process. Write a note, and because one more point is very important, that OS is the one who make a communication between the process. Okay, so who settle this communication? P1 is communicating with P2. So who settle this communication? The operating system. Operating system is responsible for the communication between the processes, or communication between the processes and the basically the communication between the processes settled by the operating system. Okay, and this settlement is called synchronization. This settlement is called synchronization. So what you have to do is you have to write like note. Okay, note. Now what is a note? OS is the one who make OS is the one who make a communication to make a communication between processes and their between the process and between the process and the communication, and this communication is known as synchronization. This communication is known as synchronization. This communication is known as synchronization. Very important point. Very important point. Okay. Both the processes are communicating with each other with a one shared variable. Who is responsible for that? The communication between the processes is operating system. Operating system is the one who is responsible for the communication between the processes. And this communication is called synchronization. This communication is known as synchronization. Okay. So I hope you understand about the synchronization. So we discuss about this communicating process very detailed. Why we are discussing this communication process? Why not independent process? Because independent process are basically doing their work and they leave the CPU. Okay, they are not changing anything to the other process. But what happened in the communicating process, if P1 change something, P2 grab that change. If some other process come, other process grab the changes of a P2. So the new process, the new coming process basically grab the changes. So it's very important to understand the changes, understand the communication, so that correct communication is transferred from one process to another process. Okay. So what is the need of synchronization? Synchronization is needed between for the communicating the process to what to expect the result, to get the expected result, to get the expected result. So what is the need of synchronization? So the need of synchronization is needed because, okay, so synchronization is needed uh, where between the processes, between communicating processes to get the expected result, to get the expected result, to get the expected result of basically the execution, expected result of the execution. So this is what a need of synchronization, so that whatever the result we want, we get that result, we get that expected result by the communication of the processes. Okay, we need 10, so one process change that value, other process grab that value. So this is how this is what the need of a synchronization. Okay, so we understand about the need as well to get an expected result. Now the next is, there is any problem if the two processes are communicating, so there is any problem taking place while communication, or what basically the problem can the synchronization basically have any disadvantage, any problem? So the answer is yes. Okay, so problems problems first of all we discuss about the problems without synchronization. Okay, what happens if synchronization doesn't taking place, the independent process is basically working, then what basically the problem arise? Okay, because synchronization is developed because there is some problem. So this thing, the synchronization thing basically solve that problem. So that's why this thing is in a use. Okay, so what kind of a problem does synchronization thing solve? So synchronization basically solve the problem of inconsistency. Inconsistency. Synchronization problem solve inconsistency, because if the one process solve something and other process solve something, both the process if get the same value, same thing, so we are not getting the expected result, what basically we needed from this particular task. Okay, so inconsistency means one process, let's say the one process basically perform something and other process perform something. let's say we have a shared variable. Okay, we have one shared variable, let's say process P1 and P2. P1 access this shared variable, perform their task and get a result. Let's say result 1. Other process get that shared variable, perform their particular task which is different from P1, and we have a result 2. Okay, but the expected one was different. The expected result was different. Okay, so the inconsistency in the result is basically taking place because both the processes are not communicating with each other. One process took that value, other process took that value, performed different tasks, and both the processes are not communicating with each other. So let's say P2 needs something which is done by P1, which is done by P1. P1 performs some tasks and it changed the value from x, it basically assign value of x to 10. But P2 from a shared value get the value of x is 54. So P2 solve a process with that particular value, but the result, the expected result will get from this value. P2 solve a process with this x is equal to 54 to perform the things and get a result which is result 2. But the correct result will be get from the x is equal to 10, which is done by the process P1. So if both the processes are not communicating, then how they can use their things? Okay, so that inconsistency is result taking places. So the if inconsistency is resulting in place, this is what the solution of a synchronization. If both the processes are communicating with each other, then easily P2 can get the value of x, and this inconsistency is not taking place. Okay, so this is what a problem without synchronization, that inconsistency of data means not get expected result, not getting an expected result. And what are the problems? Like loss of data, loss of data. Loss of data is also taking place. Means here you can see that the x value of x is what 10, but it changed x is equal to 54. It means this data is basically lost. The value of 10 is lost because 10 is no use. 10 is of no use because P2 get x is equal to 54. So loss of data is taking place here, and the deadlock is also possible. Deadlock is also possible. So these are the main problem if of the processes if the synchronization is not taking place. If the synchronization is not taking place, so these are the problems which is arise, which is arise. So I hope you understand about the problem of problems without synchronization. Okay, we discuss these things in detail in our next video. In this video, this is all about this thing, synchronization, type, need, and all about this. Okay, so thank you for watching this video. Like the video and subscribe my channel and click on the next video to understand that how basically the process synchronize, how this shared variable is used, what is how basically the shared variable used, how P1 change the thing and P2 grab that change. So for that, what you have to do is click on the next video.